Bill.
Whenever you like. We'll make it
Okay.
easy on you.
All right.
We're not going to, we don't really hold anybody to a fixed time anymore. Just let you go. If you go too long, well, you know people will leave for lunch.
Well, I'll shoot for an hour. So, okay.
Good morning, good afternoon, good evening to people around the world. This is your host of the DB2 Night Show, Martin Hubel, and we have a Z show for you today. It's going to be a great one. We've got Tony Andrews, speaking of Themis, speaking on DB2 ZOS version 9 to V12 best developer features. This is going to be a great show. Tony, how are you doing today?
Tony is doing great. Thank you.
Oh, that's great. All right, let me get through the housekeeping so we can get on to you. As good looking as I am, people want to hear you because you're good looking too. Here's our social information. We have the LinkedIn group. We have the Twitter information there on following DB2 Night. I've been trying to do a better job of announcing shows to get people to come. And of course, the replays are still our most popular feature. And we'll be putting this show up on our replay blog at the end in case people can't get to a Friday at 11 o'clock on the East Coast or 10 o'clock in the Central. And here's our disclaimer. Everything's copyrighted by various people. We work hard to respect people's copyrights. Everything's being recorded, and everything's copyrighted DBI. All rights reserved, and you can look forward to a replay put up sometime between now and Sunday, depending on how energetic and how busy I get on other things. I've got an interesting client situation right now, so sometimes I spend more time on that than I do on other things. So, but we'll get this done. All right, today's show, we've got quick announcements, studio audience polls as always, and then followed by Tony, and I'll be taking questions throughout the show through our Q&A tool. The questions are in the tool in your interface. If you go to webinar, if you put your questions in there, I will take them and announce or do a brief interruption with Tony to make sure your questions get answered. And I'm pleased to see that we mustn't have a technical difficulty because nobody has reported that to me this morning. That's a good sign. All right, moving along. Here's the upcoming shows. I have speakers lined up for the DB2 LUW edition as far as April right now, although I keep meaning to ask a couple of good friends to speak on February the 14th. We've got Michael Rookin on January 10th. He's going to be speaking on advanced log space management. And we've got Toby Haynes, who's into PureScale, and Kerry Romanoff, who is the principal architect of DB2 LUW, speaking on April the 3rd. So we've got some great shows coming up. It'll be good stuff. Next month on DB2 on Z, we've got Craig Mullins doing some things from the new book he has. He's coding for application programmers, or performance rather, by the book. And I don't know whether it means looking in the book or by his book. But I think both of those would be true, and I don't think Craig would mind if you bought his book at all. We also have the iDoug show, and we also have Dave Belke lined up for June as well. He's a regular presenter on the DB2 Night Show. He speaks normally in the spring time frame, and he's already taken our June date. So I'll put that up the next time we have our things, and I should have the February shows lined up by the next time you hear from me, as well as other shows on DB2 on Z. All right, moving along. As always, our founding sponsor of the DB2 Night Show is DBI Software, and they invite you to watch their video. And if you do that, they will send you a gift card, and it's available on the DBI Software website. The link being there on the demo. Easy to find from their homepage. Okay, another couple of shameless plugs here. Seeing as Tony works for Themis, I thought it would be appropriate to announce some upcoming classes. And yours truly also teaches for Themis. I'll be teaching a class on DB2 LUW database administration at the end of February for 4 days. And information is available at themisinc.com. And Tony, we've listed a couple of your classes there for next month. We have January 13th and 16th and January 27th to 29th on DB2 ZOS performance and tuning and on DB2 stored procedures. And that second class applies to both LUW and Z. So if you're in the market for some education, those courses are well worth considering. Here's our winner, Charles Eulery of BNSF. Won our gift certificate from our last week's show. Congratulations. And again, thanking our sponsors. And at some point, Tony through, I'll do a brief commercial of an up-and-coming DBI product when you have a break in the action. They'll do that. And with that, we'll move on and do our audience polls. Pop those out of this thing and put them over here where I can actually work with them. And standard questions today. What's the latest version of DB2 Z that you're running? Nice to see that most people are on to DB212 now. That's a good thing to see. And with that, I'll close that off and share the results. See, we've got some people running some really new stuff, and that's great to see. Mostly, I guess half the audience is function level 100 or 500 and new function mode version 11, but half the audience now is on to level 501 or higher. That's good to see. All right, next one. Which of the following commercial databases do you work with weekly? And, assuming the first one gets a tick mark there. It should allow multiple, let me hit the launch button. You can dress me up, but you can't take me anywhere some days. Pardon me. I'll just close that off, share that result. Of course, I'm not sure why people are not running DB2 LUW or Z, but it seems that might be the case, or either that or I buggered up the poll, but I think that allowed for multiple things. We'll hide that. We'll we shared that. Move on. And, which open source DBMSs have you worked with, or do you work with regularly? For people in the Z world, chances are you might very well not be working with any open source. You're working mainly in the Z world. But, just putting that in. I won't wait too much longer on this. We'll move along and share the result on that. We see Postgres SQL showing up. It's the only one today. And the next one is just an idea of how experienced is our audience right now. This is always interesting to see from time to time. Tony, where do you fall on that scale?
I'm at 20 to 30.
Oh, all right. Wow.
Yeah.
I'm afraid I'm up at, 34 years now.
No wonder you're so smart all those years.
I've been at it a long time. No wonder I'm so old. There are younger people out there that started at the same time I did, but I started in September 1985 as soon as it became GA. So there we have it. We've got no newbies. We've got some. It's funny how you consider 5 to 10 years is still a heck of a lot of experience. fact, I was teaching classes for DB2 when I had all of 3 or 4 years experience back in the day. And just a quick one on the roles, just to see what type of people we have today, whether we attracted any developers in. This can often be seen. We find that our show is primarily aimed at DBAs, but every now and then we do get some other types of people in as well. And with that, I'll close that one off. And we are mainly dealing with a system-related audience, and well, DBAs are obviously as well doing application work. So that's our audience for today. And with that, I'll hide that. And you should be now seeing my screen again, so I'll move it along. And Tony, you're up. I'll make you a presenter. Take it away. I'll stay online. I'll mute my mic just so I don't cause any interruptions. And but I'll jump in if there's a question.
Okay. Just verify you can see the screen.
Yes, your screen looks great.
Okay, super.
All right.
Okay, thank you, Martin. Good morning, everybody. Happy Friday. Happy holidays coming up here. Last couple weeks of the year. Exciting times for everybody. Like Martin said, my name is Tony Andrews. I live in Columbus, Ohio. I'm actually doing this webinar from my home office in Columbus, Ohio. Themis is a company I work for. They're based out in New Jersey. Us instructors, consultants, we typically work from home or we're on site somewhere doing some consulting or some training. So just real quick with me, my background comes from the developer side, and most all the classes that I teach have to do with development, performance, and tuning. I do teach entry-level DBA. But we have other stronger DBAs at our company that been around for like years that teach, the higher level courses, there. But I come from the developer side, always been a developer. I love being a developer. Never really wanted to get into DBA because I just like the development side. Although I was an application DBA here and there on some projects. And so what I do in my training, my speaking engagements in North America and Europe at the big DB2 conferences and stuff is developer related, because I find in the industry out there that developers need educated. And my goal has always been to get them more educated, get more material out there for them, empower them to become stronger in what they're doing when it comes to coding skills and when it comes to performance and tuning. So everything I kind of do and teach, I put a slant on performance. We all know, or many of us know, that most performance issues stem from the application side. And with that being said, if they follow standards and they follow guidelines, they get educated in some areas, that can be minimized, and it can take a lot of pressure off DBAs. So I find people that have been out there 10, 20 years coding DB2 SQL, and are they really 20 years experienced? I find often the case is no. They've just been coding for 20 years. It's kind of like 1 year of experience, 20 years in a row. In the last 4 or 5 versions of DB2 on the Z side, and this kind of relates to LUW also, there has been a lot of great stuff for developers. And overwhelmingly a lot of stuff, actually. There was so much that we at Themis, I actually was the one that was put in charge of this, is putting together some application classes for all the new application things, optimization wise and SQL wise for developers as these versions came out over the last 5, 6, 7, 8 years. So I'm going to hit what I consider my favorites out of all of those, what I consider some of what I see out there, what I've incorporated in applications that I've worked on out there, and a lot of the stuff that I think should just flat out be standards for developers when they're putting together new applications, maybe doing some changes. And when it comes to coding skills, developers I find are never as strong in SQL as they should be. One of our most popular classes that we teach for developers is an advanced SQL class. And And it's amazing where developers come into that and they realize how much they did not know. And a lot of it has to do with getting stronger in the language, because you get stronger in the language, you can figure out different ways to code. When you figure out different ways to code, you can figure out there's different optimizations that take place oftentimes when you code things differently. So I'm going to hit you. I'm going to spend about an hour here, a little bit less than an hour, and I'm going to roll through these rather quickly. Each topic could easily be spent talking 15, 30, 60 minutes on some of these topics. A lot of these topics are incorporated in our classes that we teach, with a lot of hands-on coding, a lot of workshops, that people do in the classes. So you're going to see. I'm going to go through these pretty quickly, because I don't really have that. I want to show you a lot of the ones I think are important, but I don't really have time to spend 5 or 10 minutes, delving deep into them. But I'll give you enough to kind of open your eyes to some of the things to think about. All right. So questions as they come up, we'll try to hit them in the chat window if we can. If you have any afterwards and would like to contact me, here again is my tandrews@themasync.com. Feel free to email me with some questions or a little bit more information or something, and I will be glad to help on any of these topics. So I want to highlight in this presentation some enhancements and features that I found useful, many of which I think should be incorporated into SQL and application standards. I find a lot of companies out there, they do not have SQL programming standards. I think shame on them. I think no matter what the programming language is, SQLPL, SQL, COBOL, Java, .NET, there should be standards. Every programming language has some really good things and efficient things that it can do, and every programming language has a lot of inefficient things that it can do. In the SQL language, there's some things to me when I'm on projects that if developers code things certain ways, there is no way it's going into production. You got to have some standards, and you got to get the developers educated, because there's a lot of ways that you can code things in SQL. Some are very efficient, some are extremely inefficient, and it's kind of that way in a lot of programming languages. Got a lot of good, great SQL example takeaways, and hopefully everybody gets a little bit more empowered by the end of this here. Okay, so I'm just going to kind of show you in these first few pages, and I'm not going to talk about each of these, but going back to, and this is kind of the same way, a lot of the topics I'm going to talk about today relate to LUW also. And I don't remember exactly which ones aren't on LUW, but I would say in general, most of what I'm talking about today is, okay? Here's a lot of things that came up in version 8 of DB2, specifically for developers, and that's what I put together here. Here's some things, on version 9. Here's 12 of them, different things here. Here's some more, like 20 or more different things specific to developers when version 9 came out. Version 10, 13 plus, a lot of different things for SQL developers, no matter what language that they're coding in. Some can be a little bit specific to COBOL. Most of them are not very specific to COBOL. And there's a lot of great things in here that we're going to talk about, the next so many pages. And here's some other things in version 11. As you can see, so what I got 10, 20, 30, 40 plus different things specifically for developers over the last 4 versions, and then we get into version 12 here, and not as much in version 12 as the other ones, but that's some really good stuff. In fact, a couple of these I'm going to be hit in today's presentation. Okay. Merge statement came out many years ago. Very good if we have in development, if we have something that we have some key value from somewhere, and I'm going to go either insert it if that key value is not there, or I'm going to do an update if the key value is there in a table. And the reason for a lot of things in SQL over the last so many versions is to minimize the number of times we as developers leave our program code and go to DB2. Or if I have a whole script of queries, in a query tool, How many queries am I running through that script, that's being sent from my query tool to DB2? The more back and forth, the longer your process runs. So instead of me going and doing a select to determine whether a row is there or not, and then follow it up with an insert or an update, I can send a merge. It's going to do one of the two things here. Okay, great. The thing's been around for a long time. It minimizes the number of times back and forth. If I have a batch program that generally processes about 10,000 records every night with this kind of logic, this is 10,000 times I send a statement to DB2. Prior to this, it would be 20,000 times I would send to DB2. And a lot of developers will say, yeah, but most of the time I insert, so I just fire off an insert. If I get a minus 803, then I go back with an update. Well, those worked. This is more efficient. And the generating of the error minus 803 has some overhead to it, okay? So it's that whole minimizing back and forth and back and forth. And I try to tell developers often, I talk about coding relationally versus coding procedurally. Coding procedurally is step by step by step by step. Coding relationally, let's get all of our logic in one query if we can, and the things will typically run faster. When we got into version 12 on the merge, we can now put other conditional logic in our wins. I can do a delete and I can do an ignore. Okay, that's great stuff. Prior to that, it was either I did an insert or I did an update. In version 12 also, I can pull my information from one table and do my updates, inserts, deletes on another table. Here's an example where I'm pulling employee numbers and salaries from the emp table, and I'm using some of that in my when logic, match with some conditions, and depending on the conditions, I'm going to do certain update statements or deletes or inserts, or maybe I just ignore it. Okay. So it gives me a lot more flexibility there on what I want to do. It's not just a straight insert or update. There's conditional logic I can put in there, and I can go read from one table and pull the values from that to go to another table. Great way to keep some tables in sync. Another great SQL thing was that came up. This goes back to version 9. Is a couple of key words in SQL: final table and old table. Okay, final table is I can do a select with an action like an insert, and after that action takes place, this is what I'm going to get back in the select. This is great for those application tables where when we do inserts, it gets automatically incremented key value. Either through a sequence object or through the other way I'll show you here, through the identity column. Okay, let me back up. So typically, if I go and I do an insert in an application program and it's auto-generated key that happens from DB2, I'd like to know what that is. I need to either go insert into some child tables, I need to bring it back to a screen, I need to put it on a report, I need to do something with that key value. So again, we're minimizing back and forth and back and forth. Here I can do a select from final table. Those are some key SQL words. And after that insert takes place, that's what comes back to me. If I have that in a program, I'm going to do a select into, exec SQL, end exec, depending on your program language, with your delimiters. That's great stuff. And you can do the same thing if you have some older tables that have the identity columns. Okay, with the identity columns, that definition is built right inside the create table. And when you come in and you do an insert with an identity column, we don't mention the key value. We don't mention the key column. It'll automatically be updated. I can just select that from final table, and I do my insert, and I get that back all in one statement. Great stuff. The one thing problem with the merge was when we did merges initially, okay, and we'd get an SQL code of 0 back. It was like, hey, that's great. SQL code 0. Okay, what did it do? Did it do the insert? Did it do the update? There was nothing that came back in any kind of messaging from DB2 that would tell us that. So what they came up with was to take advantage of this final table logic and allow us to include a column to our own definition. This is one where I include something called UPD_IND for like update indicator. You can call it whatever you want, character 1, and I update that when I do my update or my insert, and I select that back from final table. Final table says I want you to get these pieces of information after you do the action. The action in this case is the merge statement. So when I get my update indicator back after this merge takes place, I'm going to get an I, or I'm going to get a U, and I can start adding to my appropriate counters. So they built that logic in final table. We can also use old table. Old table is something that keywords in SQL, and we're going to select the columns that I want before it does the action based on what I want. So what this is going to do is if I run this query, it's going to delete all the employees that are part of D11, but I'm also going to get all these employee numbers and their last names back that are part of D11 that were just inserted. I'm sorry, that were just deleted. So for those of you like, say, COBOL programmers or something, you would set this up in a cursor definition. And you would open that cursor and you would start doing your fetches. If there's 9 people in Department D11, you would like do 9 fetches, get plus 100 on your 10th fetch. There's your list, but the rows are gone. Okay, they've been deleted. Another great thing that's come along with version 9, version 10, version 11 is we can now put a select statement just about everywhere in SQL. And this is where we get into a lot of this in our advanced SQL classes. And to me, this is something that developers should really know about because this is really performance related here. We can put selects in selects. We can put selects in froms. We can put selects in withs in the with statement. I can put select down in my having logic. I can put select in the middle of a case statement. I can put selects anywhere in my SQL statements anymore. And people often ask, well, why would I put a select there? Why would I select up on a select? That doesn't make any sense. Why would I ever do that? And we go over that a lot in our classes. And it's great for bringing detail and aggregation back at the same time. But the key I wanted to drive home here is not only can we put selects anywhere within SQL statements anymore, we can now do an order by and a fetch first in those SQL statements that we could not do a while ago. So anywhere you put a select statement, I can do an order by and a fetch first. That's outstanding to me when it comes to like some logic and some analytics that we're doing and bringing the information back. It's great stuff. So I love that. Great feature. Most developers out there are probably going to think, well, I put a select in a where clause like with for subqueries. Select in a from, a select in a with, a select up in a select. I don't know. I've never quite seen that before. What I find is most developers out there in the industry, I kind of joke about it. They're all coding in the 90s. You know, they're not coding relationally very much. They're not coding any of the new features very much, and most of the time it hurts performance. That's the big key. So these are some things that I especially like to talk about in some of these iDoug conventions to like drive home. And we've been trying to get more and more and more developers out there to the user groups, more developers to these DB2 conferences, more developers and things like this. So I see that you know, from the poll, most of you are DBAs coming into this. Any other time, like I'm doing a show or there's a development kind of show, I would like each of you to bring a developer or two with you to these things. And they're the ones that especially need to get more educated in the areas of DB2, in my own opinion. A couple new things in SQL. There's an intersect all. There's an accept and an accept all on the next page. They're coded very similar to the union and union all, where we have one select and then you use the intersect or intersect all in between that and another select. And what this is one way to find out some values in one output that exist in another output. Okay, it gives us another way for like existence logic. But the intersect all, really, when we have a many-to-many relationship sometimes between tables, like, well, I know we have Smiths in both of those, but how many more Smiths do I have, you know, outstanding, you know, to another? And how many do we have in common? That's the intersect. The differences we'll see coming up here. So there's a little bit of difference between these two little output queries here. If you do an intersect between these two and intersect all, these are the outputs that you get from them. This was not always so easy in SQL programming in years past, especially if you had a many-to-many relationship. Well, how many of a certain value do we have? Does each one of them have together? You know, in this case, they each have 2 Smiths. That was not always an easy thing to figure out, you know, prior to this. So developers would do some really roundabout ways in coding to try to find the solution, and not always as efficient. If I want to know, let me back up here. When you do the intersect and intersect all, it does not matter the order of which you code your queries around those intersect and intersect alls. However, when you code the except or the except all, and these are also across the board in the other relational database systems, but the other relational database systems do not have the intersect all or the except all. They do, however, have the intersect and the except. But in DB2, we have the all that we can do, which is a nice addition. When we code the except, it does matter the order of which you code your queries. You know, if I code my first query here and I do an except in my second query, what's my exceptions? Abbott's. I have some Abbott's in my first one. I don't have any in the second one. I have some Joneses in the first one. I do have some Joneses in the second one. I have some Smiths in the first. I have some Smiths in the second. So Abbott would be the one. If I reverse those, Baker would show up. If I want to see all the exceptions versus the prior one, I want to see all the ones that how many do we have in common? How many one are exceptions? Well, if I have one Abbott on the left and none on the right, I have one Abbott exception. If I had 10,000 Abbotts on the left and none on the right, I would see Abbott come out 10,000 times in my output. Okay, so the order of which we code these does matter with the exception. It does not matter with the intersect. Okay, these ranking functions have been around for quite a while, and actually I'm putting together a class right now on analytics, and in the analytics we get into using some of these ranking functions. You know, there's some real simple things that we can do with the ranking functions right here. Oftentimes, you know, I mean, I may sit in meetings oftentimes and people say, well, who has the highest this, or who has the lowest this, or give me the top 10 of this, or the bottom 5 of that. You know, and that was not always an easy thing to do without these ranking functions. I can code up this ranking function sitting in a meeting, and I can have the answer back just like that, depending on what we want to rank on. So here's a simple rank, and you'll notice if you use the rank, if there's a tie, they both get the same ranking number. And Thompson then becomes number 4. Versus number 3. If I want Thompson to be number 3, the third highest salary, no matter how many ties there are, then we go to the next page and we use the dense rank function. You can see now Thompson is number 3, no matter how many 46,500s there are. And also in the over logic, order by salary descending, I can go deeper into my logic to break up my ranking numbers. I can say order by salary descending, comma, bonus descending, comma, commission descending. And that would break them up even further. And then of course a row number, every row gets its own unique number based on the order logic that we have in there. There are there are no ties. Java programmers find this helpful sometimes, and they bring in result sets. You know, you can do a next 20, previous 20 kind of things on the in the web. Sometimes we output files or records that'll be FTP'd up to people's spreadsheets, or we create files that are going to be outputted to some other company. They want record numbers next to them for whatever reason. This is a real easy way to do that. Along with those rankings is like, okay, here's the top 5, the people that have the top 5 salaries. Now where these rankings functions come into play is especially when there's ties. People say, well, why don't I just order by descending, fetch first 5 rows only? Well, you can do that if you know for sure there's never going to be a tie. But if you have the possibilities of ties, then you want to back up here and you want to do the dense rank. because the top 5 salaries could be 8, 9, 10, 11 people. The top 5 or 10 of something could be 100 rows coming back that meet the top 5 criteria. Okay, so that's where these really come into play. But along with this is oftentimes people might say, well, I don't want just the top 5. I want the top 5%. I want the bottom 10%. So we're talking percentiles here. So give me the top 5% of stores that had the highest sales last week. I want to see them compared to the top 5 stores that had the highest sales in this period last year. You know, that kind of stuff. So how do we get that top 5%? So we can use the rankings logic with this. So the one thing about percentile logic is you got to know the total number in your data. You got to know the total number of stores, or total number of whatever you're going after. And you need to know your rank within. So example, that there's 600 students in a class and you're ranked 120th based on a GPA, 120th divided by 600 times 100 equals 20, 100 minus 20 equals 80, 80th percentile, I'm in the top 20%. So you got to understand a little bit about where these percentiles come from. So you got to know there's 600 in there, and you have to know where you're ranked. That's where the ranking logic comes into play. So here's an example. If we have an employee table, this is our standard DB2 sample table. Ours that we have 33 employees in ours. Retrieve those EMPs making the top 5% of the salaries. So here we got some dense rank going on, salary ascending. So you can see the division by 33. You have to know the number in your data. Times 100 is percentile. Then so we're doing a common table expression, and this is what you have to do when you want, like, say, top 5 or top 10, but there's going to be ties. You have to give everybody a ranking number and then go after that output of the ranking number. So it becomes a 2-step process. Common table expression or a nested table expression works perfect for that. So I'm building a common table expression here called temp rank, and I'm giving everybody a ranking and a percentile, and I'm just saying where the percentile is greater than or equal to 95. That gives me the top 5%. This is great stuff right here to me. We as in developers and DBAs, and especially data analysts and data scientists, you know, this is what I kind of call, you know, data analytics here, man. We're getting into not just that, we're getting to percentages, percentiles, and we're doing comparisons. You know, we could do comparisons against, you know, previous quarter or this quarter last year or whatever. So we end up, you know, if I output everything coming out of my common table expression, we're going to see, you know, we have the different rankings, the percentiles, and if I back up here, I wanted everybody to have a percentile greater than or equal to 95. So greater than or equal to 95. There's only 2 people that make up the top 5%. In our data, we happen to have we duplicated the first person in that sample table. For those of you that may be familiar with the sample table, we duplicated that just for some of our SQL purposes. Okay, and this is a great reason for this. So same person, different employee number. Okay, row change timestamp. This has been around for, I don't know, 10 plus years. I don't know when version 9 came out, long time ago. This is something to me that I have found in many, many applications over the years. I can go back 20 years ago on applications, and I always made sure we had an updated timestamp and we had an updated user ID. Of course, we then had to either count on developers to make sure they put those in there on insert and updates and deletes, maybe if they were going to be then moved to another table, or we had to get with a DBA to create some triggers, okay, for this. Here's an update timestamp column. We can put generated always on update. You insert a row, it's going to have that in there. You update a row, it's going to have that in there automatically. To me personally, that should be on every single new table that any DBA creates in an application. Because I don't know about you all, but I've been in a lot of meetings where there's some discussions about like, well, I didn't change that. Well, I didn't change it. Well, how did it get changed? Well, I don't even know when it got changed, you know, and there's no auditing on data that gets modified. And it just creates havoc when there's incident reports and issues that go on. And I learned that many years ago when that happened one time, and I'm in a meeting and management's not very happy and we're trying to figure out the problem. And from that point on, we went forward every application I've ever been a part of or had some say in. We weren't that. So this is an automated one. I love this. You can put logic on it then. Give me all the rows that were modified in the last, 7 days. Because you may sit in a meeting and go, well, gosh, was there any other rows modified yesterday? It seems like this one was modified yesterday, but I don't know for sure. There's not a timestamp or a date associated with it. But if I go back and look at a report a couple of days ago, it was the old value. So I'm assuming it was yesterday. What else was changed yesterday? How do we find that out? It can just help resolve and find out answers for resolution like much quicker. I'm going to go forward here just a couple pages and I'm going to back up. In version 12 now, we can add an automated generated user ID to the table. Okay, and it's based on the session ID. Okay, if I'm running out of the query tool, it's going to grab your login ID, for example. Okay, so right now, if I have those two things that are put into a created of a table, every time they insert an update, the update timestamp and the user ID of the person or package that did the action is going to automatically be put in there. Me personally, coming from the developer side, that is outstanding. That is automatic auditing. That is so easy. I don't have to worry about programmers to make sure programmers do it, or somebody, people do update statements in production code all the time to clean up. Well, when did they do it? And who did it? And how many rows were affected? How do we figure that out? I've seen a lot of updates by data analysts that have run in production before, and all of a sudden, you get called into a meeting and said, Tony, there's a problem, man. There was an update that was run by a couple of analysts last night. Things aren't looking right. We're not trying to figure out what went wrong, how many rows were, all that kind of stuff. This is just great stuff here. Let me back up here. For those programs that process a lot of rows, like out of a cursor, or they select some data for some reason and need to go back and update some of that data, how do they typically go back and update the data? They typically go back and update the data based on a key value or some kind of where logic that's going to go back and probe the index and find the value and go to the data page and do the update. Well, there's a RID function that's been around for like a long time. And the RID function is very similar to what gets put into the index. It says, where does that row live? It's an internal number. This 8708 means absolutely nothing to you and I. But internally to DB2, it knows exactly on that table emp what page and what offset that row for 00030 lives on. So if I need to select data already and I'm going back to update it, some of the rows or maybe all the rows, I'm eventually going to go back and update. I can grab that RID, and when I go back and use that RID in my where logic, it's called direct access updating. It doesn't go probe the index again to refind it. Every time you probe an index, you're going to have get pages, count up. This is a direct action. Now you have to kind of watch these days, because if there's any time period by the time I get a row and by the time I go back and update a row, we have all these utilities that DBAs can run now, during the day, and their reorgs run during the day, called online utilities, and they can reorg. And when they do reorg, rows get put back in a cluster in order, and the free space frees up, and all of a sudden rows are living in different addresses. So what we tend to do is we use that timestamp that's in the table. We use that automated timestamp that's on a table. So then when I use my RID function, when I do my fetch, I want to get my update timestamp too that's sitting there. When I go back to update it, I want to make sure that my RID and my timestamp matches. because if my RID for some reason hits another different row due to the fact I got caught in the middle of this reorg. Now that I have not personally seen that happen. Most of the time in program code, by the time we retrieve a row, we go back and update it. We're doing it like pretty fast, okay? But this is a safeguard here. Let's just make sure that the RID, which is the page in the offset a row lives on, has not changed from the time that I selected it to the time I go back and update it. We incorporate the update timestamp. To get a plus 100, then I'm going to have to go back and reselect it again. Okay. User ID auto-generated. Okay, we have these moving sum and averages. You know, again, some different analytics here that came about with the ranking functions. Well, the next version after ranking functions. This is good stuff to get. We're getting some detailed data, and we're getting some aggregated data at the same time on the same line. This was not always an easy thing to do for developers. And in fact, most developers would break this up, and for every detail, they would go branch off and execute some other query to generate some sum of salary or average or whatever they want. And they're breaking up their query into multiple queries. And what does that do? Makes their process run longer. So we can incorporate this now, and we can do a sum or some averages based on some different logic. Here's one that's just a typical sum based on our output coming out in ascending order. It's just going to sum the rows, and we finally get down to this last row here. It's the sum of all the previous salaries. So it's any row's current salary plus any of the previous salaries. That's where the unbounded preceding comes into play. That precede was kind of covered up as preceding. Excuse me, is what that says. Here's one where we can actually add a partition by, and the partition by, in this case, department. For every department, it starts over from lowest to highest and lowest to highest and lowest to highest. And you can get real tricky on this. You can say where, rows preceding, 2 rows and current rows. So it's like a 3-row moving average. If I was doing the average salary, for example, I could do current row and previous row only. So it's like a two row. Every row that you look at, the row next to it is that current row and the previous row added together and divided. But we can do a lot of this. This is where we get into some analytics. And analytics is big these days. Everybody wants to analyze data, slice and dice it, and more and more. And actually, a lot of the analytics that people are looking at today are things I can remember on projects before, or coming out of meetings I needed to go figure out for somebody. And today's SQL makes that a lot easier to kind of come up with. How about trends of like average salary based on a hire date? This is where the job is like greater than or equal to designer. So we want average salary over by job. We're going to order it by hire date, and we're going to rows unbounded preceding. What's this going to look like? So here's the ones for just the designers. So as these people were hired over the years, what was the average salary of all the previous ones at the time that they were hired? So here's somebody that was hired in 1972. Those of you that are familiar with the DB2 sample tables, DB2 goes back 35 years. The data goes back 35 years and then some that are in those tables. So this person was hired at $25,280. The average salary prior to that for this designer job was $27,620. It got hired above the average. But then as we look at the output of this, we start trending. We get down to the later ones, and the salaries that they're hired at are way below the average of everybody that was hired before them. So we kind of see a little peak in the trends and then trending down. And when did that peak occur? When did it start going from above to below? I mean, this is great stuff. This is analytics right here. And it's a simple, I'm going to back up a page. It's a simple average salary over. And we put this information in there. Again, this is a lot of stuff that we kind of hit in our advanced SQL classes. And then we give them like workshops and problems, and they have to go write up the queries and look at the solution, their own solutions and such. Okay, there's a lot more examples could give you on that. Timestamp. We can now have timestamps up to 12 microseconds. Okay. So we can cast a current timestamp, to a certain precision. We can define it in a table to up to 12 microseconds. This is big for those tables that have a timestamp column as part of the unique primary key. Because nowadays, if you set things up right, we can do thousands of inserts per second. And people like over the years have gotten duplicate inserts because they're going down to the 6 microseconds was getting duplicates on their insert processing going on. This is where this, to me, comes in really handy, being able to make that precision more deep, up to 12 microseconds. So you can select different timestamps, like you said, timestamp a time zone, and you can also define that in a create table definition. If I just create this as a timestamp, you're going to get to 6 microseconds. Currently committed data. This is something, when this came out, I could automatically think of a couple of projects that I had worked on many years previous where this would have come in quite handy. So this has to do with like bypassing some locking. When you get a minus 911, what happens in that minus 911? Well, you're trying to do some action on a row or set of rows or something that somebody else has control of. They have a certain lock on that's keeping you locked out. The biggest lock is called an exclusive lock. It's an X lock that says, hey, when I got an X lock on there, nobody can do anything. Excuse me. But a lot of times when I saw some minus 911s occurring in some online transaction processing, or some little batch jobs that were running off and on during the day to create reports, they were getting locked out due not to updates, but to inserts and deletes, because all three of those create the same X lock. So going in with a bind option or a prepare option for this current access, currently committed, then if I go to get data off of a page that has an X lock due to a delete, I will pick up that delete. Whoops, excuse me. I will pick up that delete. Because that has not been committed yet by the process that has the delete lock on there. And if it's an insert, I will get the deleted, the so-called deleted row, because it has not been committed yet. If it's an insert, I will not get that row. Okay, so I can still get to the data on the page. I won't get to any inserts that another process put on there. The page has an X lock on it, but I can still get to that page of data. Okay. That's a great thing. So you have to kind of know sometimes that when people get minus 911s, most of the time it has to do with exclusive locks. Where did the exclusive lock come from? Was it an insert, update, a delete? What was going on at the time? This is a way to bypass insert and delete exclusive locks. You will still get locked out due to an update and get put into the queue in a period of time and possibly get the minus 911. I like that one. Okay, trying to page forward here and have a little bit of trouble. All right, well, you're going to have to hang on 1 minute. I seem to be frozen on this page for some reason.
Why don't I take over and just do a brief commercial break?
That sounds great.
That way,
Let's do that. Thank you, Martin.
It's kind of funny. I can see your cursor moving around. But
Yeah, I'm clicking,
how about
clicking
using the
everywhere.
arrow keys?
Yeah. Okay, let's do that. That sounds like a great idea. Thank you.
Yeah, no worries. Got to pay the bills here. I just have to. What does this button do? There we are. There. I'll just come back over here and do a brief thing. DBI, as the founding sponsor, likes to just give you a brief message of what they're working on, and they have a new performance console they've developed that with their web performance suite that allows the DBA to see all of their servers. This, of course, is based on DB2LUW at this point, so I won't spend a lot of time on it today, but it gives you an idea of all of the monitor databases, and the purpose here is not only to allow you to quickly find problems, but to also allow you to see trends and also ensure that you're meeting service levels. So with that in mind, they have some other graphs they provide based on time of day where you can isolate using near-term history problems and go back and look at that quickly. Anything from CPU load to memory usage, reads and write times, and that sort of thing. And building trend graphs as well, also taking into account any changes that were made for system parameters, and then looking at things like the service level attainment and that sort of thing on this final page. So with that, I'm going to ask Tony now if he's back and available to take back over.
It seems like it. Let's try.
Sure. Just a second here. Make presenter. Yes, there you go. And it's all yours again. And we see your screen. You're into XML.
I'm just going to keep it like this to go forward here. Just in case.
Twice shy.
There we go. Okay, XML. I don't know how many of you are involved in any kind of XML programming or processing. Once we were able to put XML documents out there as an XML document type versus a character large object, that gave us the pure SQL language to go query, put indexes on these. We can go query through, find out that everybody that had a certain service date by a certain doctor, and that information happens to be in the XML documents for all the patients in our table, for example. So there's been some great things, here's a typical XML document, patient ID, name, address. You got service dates that could be 0 to many and all that kind of stuff. And if you have any XML, this is really good stuff for developers to learn how to code against, because sometimes the information that we want to get an answer to happens to be inside an XML document. It's not in our relational table, although a document's tied to our relational table, but it's in its own table space and in its own XML format. So reasons for XML, over the years. So here's some real simple selects. If I want to select against to see what's inside documents that might meet a certain criteria, give me any of the patients that actually have a service node in there. They've actually gone to at least one doctor, or give me the ones that actually have a home phone, or bring me back all the names of patients, or give me back the addresses for the patients that come from New Jersey. Very specific things of information inside the documents. And now we can actually put indexing on there. We can put indexing on pieces of the documents, okay? So a lot of times we can write queries and say, hey, give me all the patients, based on this certain code, and that code's in the actual normalized table. Then you continue on and say, and XML exists, and they have something in a document, based on a certain doctor name or something. So we're going after a certain range of patients, but then we are then also looking inside their documents to see, based on an XML exists predicate, criteria that's met. And we can build indexes on top of those documents over in that other table space file for the criteria that we would tend to look in those documents on. So, this is something we have 3-day classes, on this. how to set up, how to define the indexes, but more importantly, how do we do the coding to take advantage of those indexing? If you get your coding a little bit wrong, it's not going to use the index. And we go through a lot of examples of that in our materials. A lot of times people have created some indexes on their XML docs, but they're not seeing index access. You've got to be very specific about how you code that from the application side. So they have to work hand in hand. Here's just, hey, patients that have an existing zip code, node in there. Or we're looking for like an uppercase. We're getting something in lowercase. I want to get the documents for the uppercase. So anyway, there's just a couple of simple examples here, but to me, there's companies that do a lot of processing against the information that's in those XML documents. This is like great stuff for them. There's a lot of XML query and XML exist logic that they need to learn. There's a lot of companies out there that they still bring the whole XML document in as a character large object into their program, and they string through it programmatically. That's so inefficient. And why is that? Well, I don't know this XML stuff, they say. Well, then we need to learn the XML stuff because this is like CPU. This is money, okay? And it makes it a lot easier, and it's not that difficult. I tell people, hey, look, I mean, not that I'm selling classes. I'm just saying, in 3 days, you can come out and you can know all this stuff and you're off and running. I mean, if it's something that your company wants to start doing a lot more of, what's 3 days of learning from a professional? I mean, it's nothing. Then you're off and running. And there's efficiency, and everything that we do is there's slants on performance. Because if you don't code things up a certain way, even with the XML stuff, you're not going to get good performance. Temporal tables, been around. I love the system temporal tables. I think this is also just an automatic, new application design. I mean, you make changes to data, let's log those changes. Let's just not log what time something was changed and who changed it. Let's log so we can see exactly what was changed. And these temporal system tables do exactly that. So when I created a regular table, I have to add certain columns down here to make it temporal, and then I create a history table. Has the same columns, and then I do an alter statement. Some of you DBAs might have already done some of this. You alter to tie those things together. What that does for us then is that gives me, a developer or an analyst, the ability to go pick a point in time and find out what something looked at exactly at that point in time. So, well, what policies did Tony Andrews have back in like 2014? Did he even have that policy then? What was my salary 8 years ago versus today? Was my salary 10 years ago today? What department did I work in like 3 years ago? Whatever the question is, if you have this system time temporal table set up, you can easily go into a query and look at a point in time what something looked like. That to me is just invaluable. So if I'm part of an application, either leading the application or the tech person on the application or the project manager, any new tables are going to be created, I want them to be set up as temporal tables. Especially unless we're not doing hardly any changes to the data. We add data to it, but we don't do changes. But if we do a lot of inserts, updates, and deletes to application data, then we should set that up as temporal. Because once it's set up as temporal, this stuff happens automatically. All I do as a developer is I go do it in my insert, my update, and delete, and it all happens automatically behind the scenes. And it's gotten extremely efficient. So that to me is like, hey, if you're doing any kind of regular modifications to a table, your design should be temporal automatically, because it just saves a lot of problems like down the road. Okay, couple, let me see, got a number of more topics here. In about another 10 minutes yet. Query number. We can add a query number to queries in a package. We can add a query number to dynamic queries. This is like great stuff. This to me is should be a standard, not a guideline, but a standard. It makes it easy to track explains based on queries that are in the statement cache. It makes it easy to track explains on queries coming out of a package. We can do some trending on packages as we keep they turn around and get moved back up into production like pretty often. We have these consistent query numbers that we can go back and look at old explains versus new explains based on query numbers. I've seen people that have been spinning their wheels all day long because the explain that they're looking at is they're looking at a query that doesn't match the explain, because DB2 will automatically assign its own query numbers. So, well, I'm glad you're looking at the explain, but what you're looking at is not the output for the query that you're looking at. This keeps things in sync. Again, it's all about saving times, resolving problems and issues, incident reports. Global variables. These are very similar to global temp tables. A DBA has to create the global variable, and then applications can load that, and it can be shared amongst all the programs that's in its logical unit of work, just like a global temporary table. So you create a global variable, give it a name, give it its data type. I would highly recommend that you choose a naming convention, so when somebody sees that, they automatically know that's a global variable. We grant all the privileges on it. Then me as a programmer, I can put a value into that global variable, and as I call the stored procedure, or if it's a COBOL program, call another COBOL program, they can now use that global variable in any kind of their where logic and whatever value was in there, just like global temp tables. So I can do a set statement to put a value in a global variable, and then I can use it, in a cursor. I can use it on any queries. Any programs within my logical unit of work can use that global variable. Transparent archiving. This is kind of the same idea as our temporal tables. This is specifically due to deleting rows. When you delete a row, it just gets moved to another table. It gets deleted from the main table, gets moved to the other table. So we don't actually lose the row, okay? We lose it out of our main table, but it's just a backup table that has all the deleted rows in it, okay? So that's good stuff. If I delete a row in a system temporal table, we also have that logged in the temporal history table. Transparent archiving is just for deletes, and that's it, okay? So the same idea, you create the table, you create a table like that, and you do an alter to bring those two together. Enable archive is the keywords in the alter and ties those two things together. There are some special registers having to do with archiving. Move to archive and get to archive. So move to archive says, when I delete from this row, do I want it to be moved to that other history table? Get archive says, if I select from this table, do I want it to also look in the archive table? They were both initially defaulted to N when they first came out. So, well, why would I want to create an archive table and have my default be N where I'm not moving anything to it? Nobody quite was able to explain that from IBM. So they did an APAR, because what happened then, we had to always go set that special register in all of our programs that we were doing the deletes from, or we had to do it automatically in a query tool. So it became a little bit of a problem. So there's a little bit of a couple comments on that. We now have it as a ZPARM. Grouping sets. Oftentimes when we go into pulling out some detailed data, we want subtotals and we want grand totals. We can get this all in one query now. How do most developers get the detail and then the subtotals and the grand totals? Well, they either separate all the queries out with union alls, or they in their program, and every time they get a break, they go and execute another query. They get a break, they go execute another query. They get a break, they execute another query. With these grouping sets like this, it will happen automatically. You can see here the A00s. Here's the subtotal. Here's a grand total at the end. Nulls are put into those positions that are blank. So the order by, the way you order it, it comes out in perfect order where we get our subtotals followed by our grand total. Such a simple syntax, but so powerful. was not an easy thing to do, because this is one query, that's a second query, and this is a third query. It's incorporating all of those queries here in one SQL statement. Cubing, cubing can get a little bit crazy. I was on a big project at Wendy's Corporation. They're based here in Columbus, Ohio, for a number of years, and they could not slice and dice and analyze store data enough. And we did a lot of cubing for them, but we had middleware that did the cubing, a middleware product. We didn't have this when I was working at Wendy's, years ago. So this is good stuff. Me personally, I find cubing a little bit confusing, because there's so many different pieces of logic that comes out of it. In this example here, this is only 2 columns. We're getting average salary by job within department. We're getting average salary by department. We're getting average salary by each job, and we're getting a grand total average salary. We're getting like 5 different averages all calculated up, thrown in the same output. Now you add 3 or 4 or 5 queries to that. Now you have like 25 or 30 different averages that are coming out. And how do they want that sorted, and how do you analyze that? Some of the analysts, I know at Wendy's, they like this kind of stuff. Me personally, it kind of made me a little bit dizzy looking at the output, but we gave them the output they wanted, and they did the analysis. SQL-PL stored procedures. That's a very common class that we do at Themis, even after all these years. There is an autonomous word that we can use in our SQL-PL stored procedure now, because it keeps it out of the same logical unit of work. It's autonomous to the calling program, okay? This allows me, without the autonomous keyword in our definition, if I do any kind of commit or rollback in my stored procedure, I'm committing and rolling back anything that happened in the calling program. I'm also committing and rolling back anything that may be my stored procedure called, another stored procedure. If I want my work to be autonomous, if I do a couple of inserts and there's an error that occurs, I may want to commit those inserts and go back to the calling program, and then let the calling program decide what to do. So we put the word autonomous in our definition here. Okay, it's got to be the last word, keyword in our definition. Okay, and that makes that autonomous. That was a really big improvement. So something along the lines of stored procedures, I guess it doesn't really matter what the stored procedure is written in. There should always be a parameter that goes back to the calling program that lets the calling program know in what it processed in the stored procedure, did it process okay or not? Because I've seen some incident reports when I've been out on some company sites that happened because a stored procedure was getting an error. It was going back to the calling program, and the calling program had no idea there was an error going on in the stored procedure, because there was no output parameter that would tell it, hey, everything worked okay, or no, I had a problem. On applications that I worked on, that is a flat out standard. No stored procedure goes into production without an output parameter telling the calling program what went on. Now, it's up to the calling program to check it, but at least there's something there to check, as opposed to just the call was good and it moved on and followed in, and it just created like a bunch of problems. That's the kind of things that we talk about in a lot of these programming classes. To me, it's like if I'm running the project, this is going to be a standard, this is going to be a standard, this is going to be a standard, this is going to be a standard. And why are they standards? They're standards for resolution of issues that come up, and there's performance having to do with that. Okay, we got a couple of other topics here real quick. Piecewise delete came up in version 12. We often have some process that need to delete thousands or tens of thousands or hundreds of thousands or millions of rows out of a DB2 table. Maybe it's run weekly, monthly, yearly. How do we do that? Well, there's a lot of ways to delete data out of a table. And there's a kind of a list of some things that you can do right here, okay? But what if I don't have the ability to write a program to do some of this stuff? I mean, I could do a reorg. I could do some partition rotation if that fits. But maybe I'm deleting data from across a bunch of partitions. If I need to set up a query to do this as opposed to getting a programmer involved. I want to do something like this: delete from a table where where order date is less than or order date is greater than. Okay. If I fired that up, what if it's going to delete 485,000 rows? Wow, that's a lot of locking that's going to take place. So again, what we can do here is these queries now, we can have order by and fetch first and all that kind of stuff here. Just say fetch first, so many rows only. And then go delete that, then go execute that delete again. Then go execute that delete again and keep executing that delete from time to time. And it's going to be doing chunks of that 485,000 at a time, whatever you want your fetch first to be. Or you can actually set it up. I actually coded this up as an SQL PL store procedure, where anybody can call this SQL PL store procedure and they can feed it the table that they're deleting from, and they can give me the where logic. And I will dynamically build that in, and I'll do some looping logic. Okay, here's my set statement. I'm dynamically concatenating things together for a delete statement. Delete from whatever my parameter table was, whatever my parameter where logic was, fetch first, whatever the fetch count they gave me, so that can be a variable, rows only. And once I have that in this VSQL delete, now I just go through an SQLPL loop, and I just keep looping until I'm done. And I'm doing commits every 5,000. 1,000, 100, 8,000, 10, whatever you want you feed that into the call to the store procedure. And you can go right down into Data Studio and execute any store procedure that you want. You can also do this in a COBOL program. You can feed the parameters in to a COBOL program and let it build this stuff in and do the same thing. It's going to perform until. And it's going through a loop. You know, I'm doing so many at a time. Pretty nice. Explain only. I can actually go do an explain on a package to test it out before I actually go replace it. We should take this, explain it. Okay, let me see what the explain looks like. But better yet, what I think should be done with packages is we had this access path stability that was brought to us over the years, and in version 10 they gave us an AP compare. To me, I think every single package that gets moved into production should have AP compare on it. Because what does that do? It's going to take the package that it's building and the re-optimization that it's doing, it's going to compare it to what was already in the old package. And if there's any differences between the two, what do we get? We get a warning. Well, that's outstanding. How many times have we not seen warnings till Monday afternoon when somebody says, hey, something's not running very well, and you go, oh my gosh, that was just moved into production last night. Well, my guess is probably something changed in the optimization. Well, now we have an incident report that's been created where we could have gotten got a warning on a Sunday night that came out that could have highlighted somebody says, hey, your access path has changed. Could have changed better, but you need to know that it changed. Maybe you need to do a little testing before we go forward with this. So you can do it on a bind or a rebind. It does not come into play if a package gets invalidated and next time it runs, it does an automatic rebind. It's where I control the bind and the rebind. I can put that in. And the output that comes out of that, I mean, it's kind of vague, but it does give us, it's warning us, yeah. And in the warning, let me back up there. In the warning, I can say it's a warning, or I can say it's an error. If there's ever an optimization change in any queries going into production on a package that was there before, I want it to like air out. That's going to get somebody's attention. Or I'm just going to do a warning. Okay. So, a lot of topics, a lot of stuff. Those are my favorites. Those are ones I think a lot of it should be standard. Those are ones I build in application logic. Those are ones I have coded in queries and in meetings and doing some analytics and in programs. And that's just a small portion of all the ones in the first like 5 pages that I showed you. And this is like big stuff for developers, developers need to know some of this new stuff because especially anymore, analytics is such a key word. So I just like to thank everybody for coming in, listening to me talk here for the last hour. I'd like to thank Martin for inviting me here to teach. I do this a couple times a year, and it's always developer related. So next time you DBAs, bring some developers with you. We're always trying to get them out there to get them more educated. There's all kinds of ways they can get educated without taking them out of a whole day's work or something. These are some of our classes there at themasinc.com that kind of relate to a lot of the things that we talked about here today. Advanced SQL, that's a big class of ours. SQ1010 is a very big class. That's also an advanced one where we hit some of the differences of the logic, whether you're coding on Oracle, SQL Server, Postgres, SQL, or DB2. Some great stuff in there. Of course, performance and tuning, SQLPL. Store procedures, which is not on there. And there's our themasinc.com. So that completes my material for today. You guys can email me down the road. Here's my email again. Everybody, happy holidays. Have a great end of the year. And I'll see you down the road. If anybody sees me, if they go to the IDUG conventions or I go to a user group and you see me and you attended one of these, come up and say hi to me. Thank you.
Thanks a lot, Tony. Great information as always. Very important. And it's also, as you say, there's an awful lot of developers that are and companies that seem to have gotten stuck in the 90s. We're dealing with a 35-year-old product now, and it's amazing how much new function that can save an awful lot of time, trouble, and CPU and other machine resources. And it's always good to keep up, and that's why people should come take education and go to conferences and come to the DB2 Night Show. With that, I'm going to run our last poll, which we like to run, which is, did you learn something today? And we'll get a quick vote on that. People are voting quickly because it's into the lunch hour here. I'll close that off and share the result. And no big surprise here, 100% of our studio audience learned something. That's what we like to see. Means we're doing our job here on the DB2 Night Show, and that people like to participate. So with that, I will close that off. Thank you again, Tony, for being our guest and sharing this valuable information with the DB2 community. And I believe that's about the last slide I have. So I'm going to cue the music. Wish everybody happy holidays, Merry Christmas, Happy New Year, and we will see you in 2020.
Okay, Martin. Have a good one.
You too, Tony. Take care.
Bye-bye.
Stay warm. Bye-bye. Bye-bye, everybody.